introduction. So today's talk is called Waking the Data Scientist at 2 a.m. So typically we talk about waking the DevOps folks at 2 a.m. Now we're actually going to shift the target of our pages over to the data scientist. So what we will be talking about is after we push our models into production, there's ways to actually monitor those predictions. And if we start to see things like skew or drift are the terms that we'll talk about here in a bit, there's ways to actually take action. And yeah, and I've got some useful links here. That's how to contact me. We've got a GitHub repo that powers the book, and also this website that has lots and lots of resources. We will also post this talk, and the video and all that will go to the Global AI Conference as well. So, and I think the intro was pretty clear. I've been doing lots with the community, yeah, even before joining AWS. So I've got something called the Advanced Kubeflow meetup that I've had for probably, I think, about 5 years now. It predates Kubeflow. We try to stay current with the times. So I think originally it was around Spark, shifted, and we did Spark and TensorFlow. And now we basically do pretty much everything. But the most recent focus has been Kubeflow and then quite a bit of SageMaker, which we'll be talking about here today. And there's the book there. If you want to get to the book, if you go back to that link there, you can sign up. You can get the early release access for it as well too, and we'll have discount codes and all that kind of stuff for you. So and then this is really the full book. Where we'll be focusing on today is essentially chapter 9 here, which would be deploy. We will also talk a little bit about debugger, which you can use actually during training, where you can debug. And if you think of like TensorBoard, if you've ever used TensorBoard with things like TensorFlow, you can actually get sort of insight into what's happening during training. But today's talk will mostly be about what happens after the model goes into production, which is model monitoring down there. Okay. So quick sort of high level overview of SageMaker. Today's talk will be focused on SageMaker and features therein. So we have, fully managed notebook instances. These are like Jupyter instances, Jupyter Lab. We've got GPUs, of course, powering these things. There's also a series of built-in algorithms for, common things like fast text, which is a variant of Word2Vec. Things like XGBoost, we've got forecasting algorithms. These are all built-ins. You can use those if you want, or of course you can bring your own code, which is actually, I think what we'll mostly be covering today is how to bring your own script, which is classically called script mode with Amazon. So there's built-ins, there's bring your own script, and there's even ways to bring your own container. Yes, if you have your own Docker container that's already been approved by your security team, this is something you can certainly bring into the SageMaker platform and then scale it out using SageMaker. And then, so you could also benefit from the model monitoring, which is what we'll be talking about today. We also do hyperparameter tuning, of course. This has been there for, I think, since 2018. Hyperparameter tuning, very, very common in today's world, trying to get the best model fit to our data set so that we can then make predictions with that model. There's one-click deployment. It's very easy to do. You can either do it from the UI or just one single line of code to get these models into production and scaled out. And of course, we support the auto scaling. You could set up different auto scale policies for these models or for these model servers in production. Okay, so backing up, we do have reInvent 2020 that's actually coming up, I believe, in the end of November, right after Thanksgiving, and I think the first couple weeks of December. It's completely online this year, and I think it spans about 3 or 4 weeks. But just backing up to last year's announcement, this was actually a really big year. 2019 reInvent was huge for SageMaker. We saw lots and lots of really cool features. The two that we'll be talking about today are the SageMaker Debugger and then SageMaker Model Monitor. But in 2019, we actually launched something called SageMaker Studio, which is it's really the sort of premier IDE if you want to use things and track experiments or visualize the experiments. You could still track experiments with just single lines of Python code. But SageMaker Studio is really slick. We also, at the same time, we had launched the SageMaker Experiments API, and then something called Autopilot, which is basically automated machine learning, AutoML. So lots of cool features, check them out, but the ones that we'll be talking about today are Debugger and Monitor. So let's quickly talk about Debugger. So when you're training, especially with these deep neural networks, there's lots of these connections, lots of layers happening, and there could be cases where you start to see vanishing gradients or an exploding gradient, or there's just something happening during training that you might not have expected. And this typically happens when you multiply small numbers by smaller numbers and go deeper and deeper into your network. And so what you want to be able to do is to tap into that training process and to actually look at the values of specific tensors or layers and see how the actual training is happening. And so one way to do this, of course, is to just put in your own sort of print statements, right? Debug statements. Let the actual training process run, if it takes 3 days, and then go back and then sort of use that data to then chart and find where those things happen. But what you really want to do is tap in and get notified right when these things happen. And so that's something Debugger lets us do. So here's a couple examples. Maybe you have a situation where your loss is not decreasing. So when we're training models, for example, we want the loss to go to 0. So loss is essentially the error. We are constantly making predictions during training to see how close we are to the actual labeled data. And what we want is to reduce that error down to 0 as best as possible, as close to 0 as possible. And so sometimes these tensor values, because we are limited by hardware, which if there's 32-bit floats, these things can sort of underflow and then get down to 0. And now we're starting to see lots of zeros because, and so that's called vanishing gradient, for example. And it's something that we certainly want to keep an eye on and get notified when this happens. Because what you don't want to do is to continue to pay for your training job when your model is all zeros or starting to hit zeros everywhere. So this is kind of a flashy mathematical way to explain vanishing gradients, but really at the end of the day, it's multiplying small numbers by small numbers, which then gives you really small numbers and starts to go to 0. There's also something called the loss not decreasing. So I was mentioning this, we're trying to continue to decrease. If, for example, we start to plateau like the green line here, so that top line is green, bottom line is blue. If we start to plateau and we're not actually starting to approach 0, then something's wrong. And that's a case where we do want to get notified. Yeah, so let's see how we would do that. So Debugger lets you actually capture the data. We can then automatically detect these errors and then get notified. So the way that all this comes to work is our code is running inside of a Docker container, essentially. That's being scaled out across the SageMaker infrastructure. And so periodically, we are checking the values of these tensors, and we can then fire off what's called a CloudWatch event. And this is just normal sort of Amazon speak, right, like AWS speak, and we can then set up a notification, SNS notification. So the simple notification service, SNS, that could either email someone on call, like the data scientist, or send a page or a text message, right, like something like that. Or we can actually stop the training job automatically. So we don't even have to notify the data scientist. We could just stop the training job and then let them know the next morning. Yes, however, typically people do want to know when this happens because maybe they want to log into the VPN and fire off this job again with some different hyperparameters or somehow try to address this problem that's happening. All right, so here's how you would actually add debugger to your training job. Very, very small amount of code. You would specify loss not decreasing. So if you were using something like a deep neural network here, this is XGBoost. So loss not decreasing makes sense. If you were using TensorFlow or PyTorch or maybe MXNet, you can certainly then specify vanishing gradient, maybe check for certain scenarios like overfitting. And you would set up the rules and basically how often do you want to check? Is it every step through the training process? Is it every 10 steps? And you can even customize the actual parameters. So if the loss does not decrease over 10 steps or by 50% over 100 steps, something like that, then you would trigger this rule. Okay, let's shift gears a little bit. So now we have successfully trained the model, let's say. We have pushed the model into production. And now we actually want to monitor these predictions. And so we will do this by capturing that data, both the like prediction inputs and the actual prediction outputs, the actual predictions themselves. And we could periodically sample and then compare to a baseline like data set that we were using during training. And so this is often called drift. This is called training serving skew sometimes. So we have trained the model on a particular set of data that has a particular distribution. And now we are monitoring the calls that are in the wild, right? So this model has been pushed out. It's now taking traffic, and there are sets of like inputs that are coming in, and there's sets of predictions that are being made by this model. What we want to do then is have a baseline. Maybe we calculate the baseline before the model is pushed into production. And by baseline, I mean a set of inputs that are representative of the training data set, and make predictions and then sort of capture those. And every, let's say, 500 predictions, we will compare and make sure that the type of data that is being passed in is similar to the data that model has been trained on. If, for example, new data is coming in from the wild that has completely different characteristics than what this model was trained on, then this probably is not the best model for the current situation. And so something we would do would be continuously training this model. We would flag this new data distribution that's coming in. We would then retrain the model with new data so that we have a better model. Yeah, so all of this can become really, really cumbersome without a sort of fixed or structured way to do this. And so there needs to be a way to do automatic data collection, for example. We need to be able to continuously monitor and schedule this continuous monitoring, whether this happens every 500 predictions or every 30 minutes or every 2 hours. There's also got to be some way to specify the rules, right? Like the intervals, to make sure, or if the skew is a 10% difference than what we were expecting, then that's something we want to then flag. It's also really nice to actually have some sort of visual data like analysis here, so I can go into one dashboard and see how far off we are, and then it's certainly nice to have CloudWatch integration also, because this is what actually gives us the ability to send notifications and to take action. So how does this work? There's actually quite a bit going on beneath the covers. And my company, before joining Amazon, we actually specialized in doing just this. And so I can speak from personal experience where if you're trying to build something like this, there are so many moving parts. It's actually very, very difficult to build and maintain. And so one thing that's nice is that SageMaker has built this for us. And so we can just tap into the SageMaker framework essentially to do this. So the pieces that we need, of course, are some data. So that's the S3 bucket on the left there. We then have a trained like trained model, and so that's in the middle. That was done with a SageMaker training job. That model then gets pushed out to SageMaker as a REST endpoint, for example. And then now we have applications that are sending in data and then getting back predictions. So let's take a look here. So this is actually built into the SageMaker Python SDK if you're using Python. And you can turn it on with just a few lines of code. You pass in data capture config, and that's going to configure how often do you want to sample. I typically wouldn't sample 100%. That's a lot of data to be sampling. And you then tell it where to actually put these results. And you give it some sort of S3 bucket URI. Okay, and then that's it. So basically, and so here's some sample data that was collected. It's going to create these JSON files. JSON-L is a special JSON lines format. This is used pretty heavily throughout SageMaker, where each line is valid JSON, but the entire file like doesn't have to be properly formatted. So think of it as we are just validating each line of JSON to be a like complete JSON document, but we can write multiples of them. And so this is actually what gets stored into S3. And so diving a little bit deeper, let's actually look. So this is some of the data that was captured. So here's a series of numbers coming in as a CSV. So this is actually taking snapshots of the actual input data. And this is all done within your own account. So there's nothing being shared with Amazon or anything here. This is all captured. This is put into your private S3 buckets. There is nobody else that's seeing this data. And then there's the like output. So these numbers coming in, input, and then that was the output being returned as CSV in this case. And so if we start to see these input sequences coming in that do not match what this model was trained on, and of course this depends on the type of model that we're actually deploying, then yeah, that's where we actually want to get notified. So what we would do is there's a sort of baseline sort of training phase, I guess you would call it. It's not really training, but we are passing in data that we know represents our data set. So, back here, maybe we do set up a baseline and this data does represent the type of, or the structure of the data that the model was trained on. And then, so that's called baseline. So we would generate baseline statistics and then constraints, and then we would then continuously compare those baselines to the actual real live like requests and predictions coming in. And okay, so here is the code that's used to actually suggest a baseline, and so this is going to actually generate, or this actually points to a CSV that does represent our data set. And that's what we will continue to compare to throughout the monitoring process. So now here's a little bit more under the hood about what's going on with Model Monitor. So beneath the covers, we are actually launching Spark jobs. And these run as something called processing jobs. Processing jobs were actually released during 2019 reInvent. And they're basically free-form, either Python jobs or PySpark. They could be Scala jobs. Yeah, so they could be anything. They can get in data. So in this case, it's the like captured inputs and captured outputs, and it's going to then compare to the baseline. So these run as Spark jobs, and there's this open source library that's called Deque, and it's called Deque because it stands for data quality, D and Q. They kind of spell it out phonetically, DEEQU. So I've used Deque in actually multiple places within my SageMaker workflows, my machine learning pipelines, which is when new data comes in, I want to actually run Deque and sort of get the like baseline or the sort of summary statistics on my new data coming in. And so I'm giving that as a sort of one way to use processing jobs in Spark. But here in Model Monitor, right, like you don't even really think about the Spark jobs. This is all done for you with Model Monitor. But you can certainly use Deque. It's off of the AWS Labs. It's like completely open source, works with basically any version of Spark that you want. I think the one I'm using for my demos is Spark 246. And yeah, so Deque, very, very powerful, but Model Monitor will do all this for you. And so all you do then is pay for just the actual duration of the model monitoring. So this is pay as you go. This is, pennies, tens of cents here. So very, very super lightweight. You can tell it like how many of the instances that you want to run. If you want to do more in parallel, then you could have 5 instances running in parallel and then just pay for the fractions of the minutes and hours that you are actually running. Okay. And so here's an example. So this is taking a look. So this is the actual baseline results. And what we want to do is keep an eye. So on the left are the different inputs. And so there's the account length. I think this example, we are actually trying to predict the churn. And so churn is the actual target or the prediction. And then all the other data points there, 1 through 7, are the features that are used to make this prediction. And what we're constantly doing. Yes, hey Lena, can you mute yourself there? Actually, I can mute you. I think I can. Yeah, can somebody mute Lena, please? Okay, so the fields, so the account length has certain numerical statistics, summary statistics. The mean is 101.27. If suddenly we start getting data where the mean of the account length ends up being 500 or something wildly different than what we were expecting, then this is cause to possibly retrain the model. And so you can automatically trigger to retrain the model, and we'll show you that here in a bit as well. So let's see, these are suggested constraints. So one thing about Deque, actually, this is sort of behind the scenes a little bit, but it can actually suggest to you new constraints to use. So, maybe the first time Deque or the model monitor job runs through and looks at all of our inputs and our outputs for these predictions, maybe there's certain fields that we do want to actually add or certain constraints that might be indicative of something going wrong here. Okay. So this is the whole landscape coming together. The next step is to create this monitoring schedule job or this monitoring schedule. And you could do this either as a cron type of thing or if certain constraints are met. So here's a cron expression. This is saying do it every hour, but there's also other ways to schedule based on the number of predictions, things like that. So beneath the hood, yeah, like I said, processing jobs, which are running Spark jobs that are using the open source DEEQU library, Deque library. There's then this violations report that shows up. And so this is stuff you could actually review either just using regular pandas data frames, or you can actually visualize it within SageMaker Studio itself. So Studio is not required for this, but it's really a nice way to sort of visually look at these things. And so what you could do is page the data scientists with a link to this violations report, and then have them actually look at these violations and then potentially trigger a new training run. Okay, so here's how you would programmatically look at these monitoring jobs. Like I said, these are just Spark jobs that are running. I'm going to skip over this a little bit. And yes, all of this ends up going into CloudWatch also, so you can then build dashboards around this. Okay, so here's an example. So this would be baseline drift. So for the feature age, let's see, within 10 minutes, there was some like potential drift happening here. So this can actually create a first class warning or like an alarm that then would then be sent to the like data scientists to take a look. There's many actions you can take. I'm just describing, some of the more human grokable ones where you would then point them to the details of this drift. Okay, so let's see here. I think that pretty much takes us to the end here. Let's see how much time. 12, 36. I think I actually have about 4 more minutes or so, but these
Yeah.
are the references.
You have 4 more minutes. Yeah.
Okay, cool. And there's a really, really good blog post that actually just came out, I think, back in July from one of my peers that goes very, very in depth and uses, I believe it's more, well, yeah, so part of it is the like debugger side of it. So we had talked about debugger kind of around the like middle of the talk and then finished with the model monitor. That second link there is a really, really good example of how to use debugger to do explainability, so model explainability. They're specifically looking at traffic signs. I believe the author is German, so she chose German author, or sorry, like German traffic signs. And it's the ability to build sort of a heat map or like a saliency map on the actual inputs, on the actual image, to say how that traffic sign was predicted from a like computer vision standpoint. So which parts of the little, if there's like a person crossing a crosswalk, the SageMaker debugger can actually highlight the part of that specific image that led to the prediction. So maybe not explainability as much as interpretability, but yeah, like really, really has some like really good examples. That same author actually, if you click through, has a really good BERT example where she can show how the BERT model is being visualized. And so this is something we are actually pulling into our book as well. So check those out. Check out the data science on the AWS website there. And if you'd like to reach out, say hello on LinkedIn or on Twitter. And yeah, thanks so much for your time.